Mr. Johnson, and this is Conditional Statements. A conditional statement is a statement that can be written in an if-then format. For instance, if you would like to speak with the operator, then press 0 now. Just like in algebra, we use variables and symbols in logical statements to help us understand their meanings. An if-then statement is of the form if P, then Q. And it's written like this, with an arrow. In a conditional statement, the phrase following the word if is called the hypothesis, and it's represented by the letter P. The phrase following the word then is the conclusion, and is represented by the letter Q. If you were to represent a conditional statement with a model, it would look something like this. Notice that the entire region of P is inside of the region Q. So you could kind of think of it as, if I am in P, then I am in Q. When a conditional statement is written as an if-then sentence, you can easily identify the hypothesis and the conclusion. Take these sentences, for example. If the forecast is rain, then I will take an umbrella. Well, the hypothesis following the word if is the forecast is rain. The conclusion following the word then is I will take an umbrella. Conditional statements aren't always written in that exact order. A number is divisible by 10 if its last digit is a 0. In this case, the hypothesis is the last digit of a number is 0. The conclusion would be the number is divisible by 10. Many conditional statements aren't even written using the words if and then. You just have to identify those yourself. To write those statements in if-then form, you have to identify the hypothesis and the conclusion. Points will be deducted from any paper turned in after Wednesday's deadline. If a paper is turned in after Wednesday's deadline, then points will be deducted. Remember, the conclusion depends upon the hypothesis. A mammal is a warm-blooded animal. The hypothesis would be, an animal is a mammal. The conclusion would be, it is warm-blooded. So the if-then sentence would be, if an animal is a mammal, then it is warm-blooded. In logic, we try to concern ourselves with whether something is true or false. The hypothesis and the conclusion can both have a true or false value, and the entire conditional statement itself could also be true or false. Consider the following conditional. If Tom finishes his homework, then he will clean his room. Let's construct a table of all the truth values and see if we can figure out what exactly this means. There are 4 possible cases. Tom finishes his homework can be a true statement, and then Tom can clean his room, and that would also be a true statement. The hypothesis Tom finishes his homework could be a true statement, but then Tom could not clean his room, so the conclusion would be false. Then, we could say that Tom does not finish his homework, in which case the hypothesis is false, but then Tom cleans his room anyway. The conclusion would be true. And then finally, both the hypothesis and the conclusion could be false. Tom could not finish his homework, and he could also not clean his room. In the very first case, where both the hypothesis and the conclusion are true, if Tom does finish his homework and then he does clean his room, well then the conditional is also true. We can say that because he did both, that the statement, if Tom finishes his homework then he will clean his room, is something that really happened. In the second case, if Tom does not clean his room after he does finish his homework, well then he's not fulfilled his promise, and the conditional statement itself is false. The last 2 cases are the interesting ones. You see, the conditional only indicates what will happen if Tom does finish his homework. If he doesn't finish his homework, whether he cleans his room or not doesn't really indicate whether the conditional statement is true or false. When the hypothesis of a conditional is not met, then the truth of a conditional statement can't be determined. And when the truth of a conditional statement can't be determined, well, it's considered true by default. We give it the benefit of the doubt. Consequently, the only time a conditional statement is ever considered to be false is when the hypothesis is true and the conclusion is false. To show that a conditional is true, you must show that for each time the hypothesis is true, the conclusion is also true. To show that a conditional is false, all you have to do is find one example where the hypothesis is true, but then the conclusion is false. Consider these three conditional statements. If you divide a whole number by another whole number, the result is also a whole number. Well, a counterexample of this would be when you divide 1 by 2, the result is 1/2, which is not a whole number. Since 1/2 isn't a whole number, the conclusion is false. Since you can find this counterexample, the conditional statement itself is false. If next month is August, then this month is July. When the hypothesis is true, the conclusion is also true, since August is the month that follows July. So in this case, the conditional statement is true. If a triangle has 4 sides, then it is concave. Well, the hypothesis is false, since a triangle can never have 4 sides. A conditional with a false hypothesis is always considered true simply because it doesn't make any sense. When analyzing a conditional, don't try to determine whether the argument makes sense. Instead, just analyze the form of the argument to determine whether the conclusion follows logically from the hypothesis. I know it's kind of hard to wrap your mind around, but when you say that if a triangle has 4 sides, then something, well, since a triangle really never has 4 sides, it defies the definition of a triangle, well, you can't really say that that statement's false, can you? It's just a statement that doesn't make any sense.